All right. Welcome to the Microservice and Serverless Observability talk, everybody. Thanks for showing up. My name's Clay Smith. I'm a developer advocate at New Relic, and really excited to be talking about this, especially with the announcements this morning around Fargate and Kubernetes for ECS. New Relic, if you don't know us, we have a number of different solutions for monitoring and having analytics around solutions that run in the cloud or on-prem. And because of that, we've been talking to a lot of our customers the past year and a half, and we've seen a massive amount of interest in serverless compute technology, specifically AWS Lambda. And the purpose or the inspiration behind this talk was we've seen this pattern over and over again that as people move to serverless computing architectures, the focus for this talk later will be specifically Lambda, but just in general, a lot of the assumptions and best practices and playbooks for monitoring those workloads in those serverless compute environments, it does change. And with that in mind, this talk really tries to get into that a bit, and we'll wrap up with a Lambda case study. We were running headless Chrome in AWS Lambda and learned some interesting performance things around that. And then Marcus Irvin will join us at the end for a Q&A on a recent project his team just launched in production. So to jump right in, observability has been discussed a lot, especially if you follow the monitoring people on Twitter. The clearest definition, and why I think it's important, is that it gets to an idea that's not necessarily monitoring, but it's a good conversation starter. And specifically, it has this focus on how well do we understand the workloads that we're running in the cloud or on-prem from the work that they do. And how good is that, and can we make it better to ultimately make the systems we build and design better as well? And so observability, whether you like the term or not, or just want to call it monitoring, that's not necessarily the key point or takeaway. But I think it's a really important discussion, especially as we look at these new software architectures like Lambda, or consider or try and build some sort of next generation system. So observability, I think, is really nice for at least starting the conversation around how well do you understand what's actually going on in these environments. Related, and I think also really important, is this idea of instrumentation. So we have workloads running in some service, whether it's a traditional VM or something next generation like Fargate. How do we understand what that code is actually doing when it's actually responding to an active request? And instrumentation, not a new idea at all, but it just gets this idea of what events do we want to measure in code to understand what that code is actually doing in production, responding to a real request. And so this idea of observability and instrumentation, I think, is coming up a lot more, especially when we talk about Lambda and kind of container orchestration systems, because it gets to really important ideas of actually understanding what's going on in the first place. The agenda for this talk and where we're going to go here, the first bit is really a discussion of a lot of the architectures we see different customers moving to. Since this is a serverless track talk, a lot of that should be familiar. We will go then into kind of the role different data types play in understanding new architectures, and potentially how that's different from older legacy architectures. We'll end up with some just kind of higher level requirements. And then from there, and this is kind of the more fun part, we're actually going to try and put some of those in practice looking at a large Lambda function. And then lastly, we'll be talking with Marcus with a Q&A, and there'll be time for audience questions at the end too. So stay tuned. At this talk, the AWS reInvent talks get prepared for all speakers pretty long in advance. So in the spring of this year, there was a little bit of a side project of trying to understand the history of monitoring, or kind of where we came from. And it turns out that all of the IBM System 360 manuals have actually been scanned or online. And so the really interesting question was, well, how has monitoring changed from the late 60s when you were wearing a lab coat looking at a mainframe? And surprisingly, two things stuck out that are mostly the same, at least kind of in practice. One, you want to have visibility into different execution paths. So the mainframe does something, you want to know what happens along different paths. That's still true today. And then in the event of a failure, IBM System 360 would actually print out the entire contents of memory for debugging. And so this idea of a stack trace or understanding the state of the program when it failed, that's also true too. There was some patch card stuff that we obviously no longer use though. So yes, the workplace has changed. We don't have to wear lab coats anymore. But the architectures themselves have obviously evolved very quickly too. We're looking at things on mobile, edge computing, IoT, per the keynotes announcements today. But I think that same desire or that same necessity as an operator or a developer to know what the state of the program is during its execution, that still is the same many years later. One of the most common patterns we've seen our customers migrate to the past few years is not a surprising one for anyone here. It's this idea of taking a very large monolithic application. We see a lot of these written in Java, and you're going to break it apart in different ways into either SOA or microservices. What gets really interesting, though, especially with the growth in different AWS managed services, is that as you decompose a monolith into different microservices, a lot of those components might just be fully managed AWS services, different AI tools, things like Incognito. And I think that's really interesting because even though you might be running your own code, that code is now interacting with AWS managed services, and the monitoring or visibility requirements are slightly different when you're looking at those interactions. The other thing that's pretty interesting too is that we see more customers deploying to more than one AWS region. Not necessarily a super surprising trend, but we recently did, just last week, a study of everyone using our AWS Lambda integration. And we found that generally people that were using Lambda, different accounts that were using Lambda functions that were monitored with New Relic, were deployed in a single AWS region. But there was a really interesting percentage of accounts that were deployed in many, many regions. Slightly less than 1%, a single account was running Lambdas in around 9 different AWS regions. So it's really, I think, opening up some really fascinating use cases around people running code in multiple regions around the world for different reasons. And lastly, with the improvements we've seen recently to Lambda at edge, we can now run more complex workloads directly on the edge in Lambda functions. The compute is getting physically closer to customers, and obviously IoT is kind of an extension of that as well. So globally distributed, it's getting closer to customers, and we're having more components at play with the switch to SOA or microservices. On top of all that, the compute workloads themselves are fairly short-lived. New Relic monitors Docker containers, and we did a study in early spring of this year of what's the lifetime of those containers. So how long does a Docker container actually stick around? This is the distribution, sorry for the lack of labels on the graph, but it's from 1 to 100 minutes in 1-minute buckets. And you can see here from this heavy, the distribution is very short-lived. So the median's around a couple minutes. And that's really interesting because as people move to these new environments, they're not necessarily doing this, they're not necessarily lifting and shifting the existing application architecture into a large container. It's scaling up and down, and those containers are very short-lived. So kind of interesting there. All in all, more people tell us or say something along the lines that they're running something that resembles or looks a lot like a very complex distributed system. This is just the service map. Service maps are diagrams of relationships between services. Are always good for defending how complex your distributed system is. Netflix probably has the most famous one. I think they call it the Death Star diagram. This is a much simpler one, but I guess it's the same idea that we have a simple web application here that has a database, it has a mobile web app, but the number of components continues to grow. I think the good news here, and historically, we tend to get better at operating in these kinds of environments. It's not a hopeless situation. There are certainly challenges in building and designing and operating software that's globally distributed in ephemeral components using hybrid architectures. But generally, we know that we do get better at it over time. And I think a really key part of that, and one thing that helps a lot, is having data to actually help through that process. And the technical reasons aren't necessarily all that surprising. Obviously, having good data and visibility helps with debugging and troubleshooting. Just like IBM System 360, knowing the state of the program when it fails, pretty useful. Much earlier in the process, before you're even writing a line of code, having data to validate designs. So based on previous systems, using that operational data to inform the design of next generation or new systems, what actually works, what should we build. Reducing defects, catching issues before they become a serious problem, and ultimately for the business, using all that to move faster. And that, moving faster, gets in this idea of cultural shifts, and that's how can the data actually help people work together on a team. And the one thing we hear a lot about, and this is very related to DevOps, there's this idea of building transparency across teams, having that shared reference point, especially when the components are fairly complex, and moving to this model where decisions are data-informed and not necessarily driven by guessing or kind of picking the newest trendy framework. One thing that's really important, I think, for people in practitioner roles is the ability to have freedom to experiment, try new architectures, try new ways of doing things, but not necessarily being prevented from doing that because there's some white paper that insists that there must be a single process for doing it correctly. And lastly, we get to kind of more of the post-mortem situations where when things do break, that it's not necessarily the fault of one individual or one change. It's a complex system. There's really no blame that can be associated with one person. So between all that, I think we get to this idea, in order to get to that good data, in order to actually understand what these workloads are doing, regardless of whether they run in Lambda or a Kubernetes cluster, how do we actually understand what it's doing? And I think instrumentation is a really key part of that. The really interesting question and the thing that I've been working on, especially with AWS Lambda the past year or so, is assuming we believe that data is important. I think that's a good place to start, and that instrumentation helps us get better visibility into workloads as they run and new things, specifically in the AWS Lambda environment or with different emerging microservice architectures. Fargate, obviously, is the newest one as of this morning. How do we actually make that code observable? How do we actually know what it does and how it works? We've kind of broken it down into 3 different requirements. And the first one, of course, is that there are different data types available for these different systems. And logging is great, metrics are great, traces are useful, but over-reliance on one, we find typically misses some opportunities in actually understanding how the system works. A good example would be metrics. So if you want to answer the question, is my response time slower this week or last week? Metrics are great for answering that question. You have events with a measurement over some time series, and you can answer that pretty easily if you're measuring response time in the first place. Logs, of course, the raw human-readable machine data, useful for debugging. So if the database won't start on a server, you'll inevitably be looking at logs. And traces, I think, are especially interesting with Lambda and different microservice architectures because they're actually establishing a relationship between events on different systems. So it can answer things like, what are the dependencies? Or even for a single request for a single service, what's the breakdown in time between different methods and different external calls? And I think the combination of all 3 of those, some people have called these the 3 golden data types of observability. I think using all 3 and deciding what the balance is between the 3 can be really useful in understanding what's actually happening. The difficulty, of course, is that if you have a new modern microservice you built from scratch with this mindset in mind, you might have really good observability into a single service. But obviously, it's more than just backend components, especially as we look at things like edge computing and eventually IoT. So you have mobile and browser applications talking to multiple applications that might be running in different containers or different operating systems, inside an EC2 instance, and then that, in turn, is probably interacting with lots of different AWS managed services. Having visibility into only one of these components doesn't really tell the entire story. So it's having full coverage of all of those different components together. And the last thing, and this is kind of interesting too, because there's this perception that instrumentation, manual instrumentation especially, getting full coverage across a large team in different offices around the world is a very slow process. And it's hard to get there, and it requires a lot of tedious work. And in some cases, if the service is old enough, perhaps the expert on that service you would like visibility into no longer works for the company or has moved on or been promoted to a new project. We do hear that a lot. So there's this idea, and I think this is related to this practice of observability, that instrumentation should be built into everything you run and build. And some of our largest customers in New Relic have actually started experimenting with this idea and created dedicated observability engineering teams, which is an interesting way to kind of make this a practice company-wide. So across those three things, I think it's a good point to kind of pivot to AWS Lambda itself. So I've talked a lot at this point around metrics, logs, traces, observability, how that works, why that matters. I think it's important to actually back that up with an example here. And AWS Lambda is a specifically interesting one because of the constraints of the runtime environment, and because AWS manages the infrastructure that Lambda runs on. A lot of the practices we have for servers don't necessarily apply directly to Lambda. We can't really look at host CPU percentage for a Lambda function running on the internal Lambda service, for example. So what does that actually look like? Amazon provides some observability automatically, obviously a set of CloudWatch metrics and logs. If you log to a Lambda function, it'll appear in CloudWatch. And the metrics, specifically, there's a different set depending on the service. We've got invocations and duration and throttles. The one we'll be focusing on for this case study specifically is duration. The Lambda function is a fairly large one. It's running headless Chrome, as I said earlier. So what we're really interested in is making sure the duration is fast. The function is very fast, and it runs quickly, obviously for billing reasons. The other thing, and I guess this week at reInvent it would be celebrating its year anniversary, is of course AWS xray, which is a service provided by AWS that allows you to trace requests between different AWS managed components. The really interesting thing about xray, and the really useful thing if you're going down the path of debugging AWS Lambda performance, is xray, when enabled for Lambda, actually exposes some really interesting internal details that you can't actually observe from the perspective of your application code running in Lambda. And the really big one and the really interesting one is this idea of cold starts in AWS Lambda functions. So when we talk about AWS Lambda performance, there's been a lot written about this. If you go to serverless conferences, there's always a cold start talk. But the really nice thing is if you enable xray for a Lambda function, you actually see how much time is spent in the internal Lambda service. So when the internal Lambda service actually receives the request, and then when your function actually starts executing. And so if you look at these, this table, there's the AWS Lambda and then AWS Lambda function. If you compare the difference between the two, you can actually measure cold start time. And by that, I mean the latency between when the internal AWS Lambda service receives the request to invoke your function, and then when your code actually starts running. And so there's some internal setup, obviously, that has to be done to create the environment to run your function code. Really interesting and available visually in the AWS Lambda, in the AWS xray UI. If we run this same function again, it looks slightly different. You notice there's no large difference between the internal Lambda service and your function, and that's because it's a warm start. So there's no setup time, and your function initialization code doesn't have to run either. So it was essentially looking at this xray trace data that we wanted to ask a lot of questions around performance of this Lambda function. And specifically, we know that we have different numbers in a trace, and a trace happens at a particular time. So if we aggregate the traces, and we know what time the numbers in those traces happened, we can ultimately turn those traces into metrics. And we can answer a couple of really interesting performance questions that before the xray integration existed, you really couldn't answer very easily at all. And specifically, the really big one and the important one is where's time actually being spent in the function? But more importantly, especially if you're wondering if cold starts are impacting your performance, is that an issue at all? Are cold starts actually impacting the way people interact with the function? And of course, understanding that over time. Not surprisingly, to actually pull data out of xray, there's an API. Like almost every service, this code is on GitHub. There's a Amazon CloudWatch scheduled event. It pulls data from the xray API every few minutes, and it sends it to New Relic's event database, Insights, for further analytics. And so after we've pulled in the trace data over a 24-hour period for our Lambda function that's running headless Chrome, we're actually going to be able to see what that looks like and actually kind of answer some of these questions we had around performance. And if we actually look at the data and we write a few queries around it, we see a couple interesting things right off the bat. First of all, the Lambda function itself, the first graph here, it's on a scale of 0 to 5 seconds. So our Lambda function is obviously much, much slower than the internal Lambda service. Not surprisingly, kudos to the Lambda engineering team. The Lambda service is frequently very, very fast. In this case, most of the time is spent in your function itself, or in this function. From there, we can ask the question, we know how often cold starts happen whenever this function's invoked over a 24-hour period. Does that happen very frequently? Are we actually hitting performance issues with the Lambda function? And if we look at the number of initializations that are non-zero, so this is the number of initializations from traces that actually have a cold start happening, it's very, very low. So for this Lambda function, thousands of invocations, cold starts only happened around 1.5% of all requests. We can then look into the timing information. So for those 1.5% of function invocations that actually did have a cold start, how long did it take to actually initialize my code, so my code that I'm responsible for in the Lambda function? And if we graph that over the same time period, we see two peaks, one around 200 milliseconds and one around 500 milliseconds. But the interesting thing about that and why we've gone so deep into how long that takes is we wanted to answer the question, in some cases, this Lambda function, my code takes up to 5 seconds to actually run. Is that 5-second duration actually being significantly impacted by, say, my code slowly initializing? And because it's only taking 200 or 500 milliseconds in the worst case, we can say it's fairly unlikely. Looking at that and kind of looking at that analysis, we're like, well, if we want to optimize the performance of the code running the Lambda function, it's not cold starts, it's not the internal Lambda service, it's our function code itself. And because it's the Chrome binary, so an application that was ultimately written to run on desktops, the question was, well, maybe it's under-provisioned with memory. And it turns out, if we run the same analysis again, so we look at the distribution of duration for the function code, it does, not surprisingly, get faster if we give it more memory. So just over a gigabyte of memory from 768 megabytes, it does get faster. You see the distribution shift to the left there. This gets to a really counterintuitive and really interesting point, though. By increasing the memory of the Lambda function, this actually decreased our bill. So because AWS Lambdas build in 100 millisecond increments, we made the function faster by giving it more memory. But we made the function fast. Basically, the function got so much faster that it lowered the bill because it was just executing more quickly. So it's this kind of counterintuitive point that wasn't at all clear to me when I was first kind of working with Lambda, that more resources, more memory, doesn't necessarily mean your bill will get higher. If your code actually executes much faster, it's likely your bill will go down. So a really, really interesting point around performance tuning. And because it impacts your bill, I think it also underscores for complex functions that run a lot, Potentially a lot of cost savings there as well to kind of do this tuning in the first place. I want to kind of wrap that up with a few, just a few high-level lessons, and then we'll jump into Q&A with Marcus. But I think from this case study, we were able to at least explore some of these ideas with real data. That instrumentation, whether it was custom instrumentation we built with our serverless stuff that pulled in xray traces and then data analytics, or what's built in with xray, it was looking at different metrics, different trace data, and also logs during development to figure out what was actually happening. And then once all that was in place, we put it into a solution that allowed us to really explore that. We did not know going in or putting the data in what exactly we wanted to know from the data. It was only after we explored it that this kind of insight came out in the first place. So it's that transition of going from observability to having the instrumentation to actually being able to answer and explore interesting questions. And from there, I think we'll invite Marcus Irvin up from Scripps Networks, and we'll be discussing his recent AWS Lambda project. We'll give Marcus a hand.
Thanks, Clay.
Yeah, thanks, Marcus.
Yeah, thanks, everybody. Hope everybody's having a good reInvent.
Yeah, absolutely. So, Marcus, I know you just recently and successfully deployed to production a fairly large AWS Lambda project. I was curious, though, what are you currently working on, and what do you do with Scripps?
Yeah, sure. So, like Clay said, I work at Scripps Networks. You might not be familiar with Scripps Networks, but I'm sure you're familiar with our brands. We own Food Network, HGTV, Travel Channel, Junior's Kitchen, and a few other things. I'm an architect, and I manage a team that's focused on APIs. For a long time, that was really focused on building APIs for our mobile applications. In the last couple of years, we've sort of branched out. We're doing a lot with like voice and Facebook Messenger bots and et cetera, et cetera. And from there, we wanted to leverage the work that we did on mobile and kind of started building more of a microservice architecture to be able to share some of that work that we do.
That's great. So how long have you been using Amazon Web Services?
At Scripps, we've been using it for probably about 5 or 6 years, and I've been using it for a little bit longer than that.
All right, and so tell me about like your very first Lambda project. I know you just implemented a fairly large system, but how did you get started?
Yeah, the first time that I used Lambda was a couple of years ago. We were building a new version of our Food Network mobile app, and we were using API Gateway, and we needed to do some custom authorization. And API Gateway supports using Lambda to do authorization on every request, and that was the first time I used Lambda, and it was super successful.
All right, and kind of fast forward to the past several months, you've been working on a fairly new service. Can you kind of describe what it does, and what were some of the reasons you decided to kind of use serverless for this new service?
Yeah, sure. So it's actually an old service called ReciBox. It's been around for, I think, going on 10 years or so. It was built and maintained by a third-party vendor for a long time, and it's the service that is used across our mobile apps, but also across the websites for saving and allowing users to view their saved recipes. So pretty simple in concept. But we decided that we wanted to bring this in-house. It was a service that was really important to us. And like I said, it was maintained by a third-party vendor, so it was hard for us to get changes made to it. We had a lot of enhancements that we wanted to make, and as we're exploring new platforms, we wanted to be able to enhance it. So we thought this could be a good candidate for serverless. It's at its core, it's relatively simple, and so we started doing some POCs around it, and we decided to go all in on it.
That's great. So what's the high-level architecture of the recipe box service? How did you decide to build this, and what did the initial architecture look like?
Yeah, sure. So we, like I said, there was an existing ReciBox service, so we wanted to stand up the new ReciBox in parallel, and rather than do a sort of a big bang migration, we wanted to move over apps gradually from the old service to the new service. So it's running in parallel, and then we keep it in sync, which adds a lot of complexity to it. So at the core, it's a few lambdas and an API gateway and some DynamoDB tables. but the parts that are keeping it in sync add a little bit of complexity. So we have SQS queues, we have Lambdas processing messages from the SQS queues, we have a step function that we use to do the migration part, and yeah, those are the main things.
That's really interesting about step functions for the migration, and you mentioned they were running in parallel too. So I mean, what was the process like? And we were talking earlier, it's now fully in production, is that correct?
It's fully in production,
Okay.
although we haven't moved all of our consumers over to it yet. So we have a sort of a mix of consumers using the old service and the new service.
Yeah, and so that's, I think that rollout's pretty interesting too. So how'd you verify that things were working and make sure that it was kind of ready to go 100%?
Yeah, so we decided to do it this way for a few different reasons. One is we didn't want to have to do a sort of a big bang release and coordinate amongst a bunch of different teams. And then the other thing is this is allowing us to do migration sort of on demand. So as users access the new Rusty box, we're able to run that step function to migrate users over as they're seen. So we didn't have to kind of take on the big data migration up front.
That's great. How long did the rollout take?
Yeah, so we built this service and got it into production for our mobile apps in about 6 months.
All right. So a lot of people have discussed different strategies around local development for Lambda, and there's been a lot of chatter about this. I was kind of very curious, how your team managed local development of these functions, especially because you're talking about SQS queues, step functions, Lambda functions. Those aren't necessarily available for you on your local environment.
Yeah, no, it is tricky, and I think as an industry we're still figuring this out. But for us, we found that most of our JavaScript we had it as kind of separate packages that weren't necessarily in Lambda. Then our Lambdas were fairly small as far as just calling out to that JavaScript. So we were able to execute the JavaScript that accesses the database or maybe puts messages in the queues, kind of execute that locally just against services in the cloud. And then as far as Lambdas go, and we use all of our Lambdas are written in JavaScript. And as far as Lambda development goes, it's just a function that you can technically run locally, whether it talks to AWS services or not. And then also with Lambda, it's really easy and quick to do deploys. So it doesn't take too long for us to test it in the cloud.
That's great. And part of getting to production too is obviously testing as well. You mentioned it's easy to kind of run the functions locally because it's just a JavaScript function. But how do you test before you actually do those frequent deploys? Yeah,
so we do a lot of unit testing with just your standard JavaScript unit testing frameworks. But I found with Lambda and with Serverless that there's so much integration work that really you end up with a lot more, or you should end up with a lot more integration tests than maybe a traditional app. So I think that's one thing that we really kind of focused on is writing tests that not only just kind of mock out all AWS services, but run against AWS services.
That's great. Are you using function tagging or versioning?
We are not using function tagging or versioning. We are tagging our functions. We tag, all of our functions are deployed using CloudFormation, and we tag all of our CloudFormations with the application, with the environment, and with the component type. So yeah.
That's interesting. And you mentioned deploying using CloudFormation. Is that something that's done manually or using a CI/CD pipeline?
Yeah, so we've been using CloudFormation for all of our applications for at least a few years, and so we have a lot of automation already around CloudFormation, mostly written in Ruby, but then we have that run in our Jenkins pipeline.
What else is the Jenkins pipeline responsible for?
So yeah, every time we deploy our code to master, or really any branch, Jenkins picks it up, runs the tests, and then for master, it'll go ahead and run the integration tests, and then deploy it into production. That's great.
So now that we're in production, the obvious question is, how do you monitor it?
Yeah, great question. Again, this is, I think, still another area that the industry is still figuring out, and the tooling is maybe lagging a little behind, but getting there. And you talked about a lot of interesting things just now. Probably the thing that's been most useful to us is we have our application has about I think around 15 or so Lambdas. And each of those Lambdas is writing logs to CloudWatch logs, and how do we get to those logs to do any sort of diagnosing? So probably the most important thing for us is to get those logs into a log aggregation service. We use Scalar, but you can use Sumo Logic or even an Elk Stack. So that's probably the main thing. We also use New Relic. New Relic's infrastructure service pulls in all of our CloudWatch metrics and pulls it into New Relic, where we could do dashboards and do alerting there, where we're already kind of used to doing. We've played around with xray a little bit, but we haven't done a whole lot with it. I feel like this, at least in my experience, it still has a little bit to go, but it's definitely a promising service.
Yeah, and you mentioned alerting as well. So, how do you configure alerts, or what ultimately wakes you up when it comes to Lambda?
Luckily, we've been lucky that we haven't had any major production issues since we launched. But we do have, of course, some alerting set up. We have alerting in a few different places still. We have, I mentioned all of our logs go to Scalar, so we do have some alerting there for when if our logs start showing a lot of errors, we have alerts triggered. Inside New Relic, where we already have a lot of our alerting for our other applications configured, we do alerts there on Lambda metrics, whether or not there's invocation errors or slowness. So we have some of that set up as well.
That's great. Well, I was kind of curious, especially since it's reInvent, there's a big focus on kind of the future of serverless. I think we can all look forward to Werner's keynote tomorrow. But I'm curious, are you evaluating serverless now for other systems too? And kind of why or why not?
Yeah, I mean, I think my team is definitely bit by the serverless bug. I think the question for us now will be not whether serverless is a good fit, it's like whether it's not a good fit for us. So we've already started a couple of the other small services that we're doing with serverless. So yeah, I think we'll be doing a lot more next year or so.
That's great. And what's your high-level process for determining whether something's a good fit or not a good fit?
I think for us, it would be if we needed to use a lot of sort of existing code for some reason that wouldn't maybe necessarily run on Lambda. Our team has a lot of history with using Ruby, which isn't yet. Hopefully, maybe tomorrow. Who knows? Supported on Lambda, so there could be some use cases there. But
yeah, well, I mean, I think that brings up an interesting question too. If any AWS Lambda PMs are in the room, what would you like to see, or what's on your kind of Lambda wish list for the next few years?
Yeah, well, I mentioned I'd love to see some other language support. I love JavaScript, and that's a good language. But we have a lot of history with Ruby. That would be a great language. I think Go is an obvious choice there. I mentioned earlier that we do a lot with SQS. The SQS and Lambda integration is a little wonky. There's not a good event being triggered when messages are in your queue. You have to kind of use a CloudWatch timed events to pull your log, or use a CloudWatch metric to trigger it. So I think there could be some improvement there.
Yeah, that's great. I think at this point we have a few minutes left for just general audience Q&A. We've got two people with microphones that are happy to run around. If you raise your hand, if you have any questions for Marcus about Lambda or about serverless, we're happy to answer.
So while we're waiting to see if anyone has any questions, what are you looking for next year in serverless? What are your predictions for 2018?
Well, I think we're going to see a lot more tooling, a lot of vendors adding more and more support. Because I think we're still sort of lagging behind their other things, I'm excited to see what gets announced tomorrow. I think there'll probably be some cool stuff that comes out of that.
That's great. Any other questions? Oh, I think I see hands here.
I was wondering, you talked about the serverless architecture, but what if you had built your big application without serverless? What would you expect to have been the difficulty for this service, or maybe in cost, the difference?
I'm sorry, can you repeat the question?
What is the difference, do you think, if you had built your big service without serverless?
Yeah, I think we're definitely seeing, it's kind of hard to compare, but I think we're definitely seeing cost savings. I mean, our Lambda costs are way cheaper than, our EC2 instances normally would have been. We're using DynamoDB, which can be expensive, but like you have databases in your listing app either. So I do think there's cost savings that we're seeing. Also, I think there's one thing I've noticed with serverless is you have a lot less code. I'm always kind of surprised at like sometimes how little code we have for doing such big things because we're making use of so many AWS services to do the heavy lifting.
Yeah, I was curious. I've got quite a bit of experience writing Lambda functions and serverless applications, and one of the things that we've run into quite a bit is kind of what logging framework to use. We use JavaScript too, and there's a plethora of different logging SDKs that you can use, but the concern has always been, even with tree shaking and stuff like that, getting some code bloat into your functions. So we've kind of stripped that stuff out and just used a vanilla logging pattern. So I'm just curious to know if on your team you've established any sort of like best practices or standards around how you log and instrument your code.
Yeah, so we're using, I don't remember the package, it's a fairly lightweight package that basically does your logging in a, just a simple JSON log, but then you could also set up sort of at the beginning some metadata that you want attached to each log message, so that's kind of nice. So at the beginning of the, at the event, we could say that, oh, this is maybe a user ID and an invocation ID and add those to that so that it's not quite bloated with all of your log messages. Your log messages could be just specific for what it was, yeah.
Is it okay to ask you a question, Clay?
Sure, yeah.
Okay, so I'm just, the observability that we have now with xray and New Relic and other tools, it seems a little, well, it seems a little basic to me. Sorry to say that. It feels like needs a lot more features and a lot more depth. And I'm just wondering, is that going to come from New Relic or maybe from AWS? And what are some of the key features that you think are going to come down the pipe?
Yeah, no, that's an excellent question, and I think my initial response is this is a conversation we're deeply interested in having with customers like yourself. We think we agree that we're early on this kind of journey to serverless, and we want to get greater observability. I think everyone agrees on that, but we're really curious, and actually we're currently interviewing a lot of our customers to essentially discover what's on everyone's wish list. And so it's a conversation we'd like to have, and in terms of New Relic, it's something we definitely want to be a part of.
I'll add something there though, that I do think I think tooling is definitely kind of lagging, or not where it needs to be. But I do think with serverless, there's so many more metrics that are available through CloudWatch, even though they're hard to consume and maybe to work with right now. But as far as from the observability standpoint, serverless I think is really ahead of like sort of traditional applications from what's possible.
All right, I think that's it in terms of questions. Or does everyone? All right. Well, hey, thank you very much, and thanks again for Mark.
Yeah, thanks,
Marcus.
Thanks, everybody.
Yeah.